Alright, so here's an example. Says Joey was only 120 pounds when he decided to lift weights and eat more for the next football season. It has worked, and he is gaining an average of 3% of his weight each month, as shown. How much will he weigh in 1 year? So this is an exponential growth problem. Here's Joey, he's a little guy, 120 pounds, he wants to get bigger, he's eating, he's lifting, he's gaining 3% a month. So I have to add 0.03 onto 1, so his growth factor would be 1.03, and it says, how much will he weigh in a year? So here's what happens as you put the months in here, times it by 1.03, and the time is going up, up, up. And what happens, you guys, this curves. This is not a line, because what happens is you have a compounding effect of the multiplier, the 1.03. So the equation here, remember we have to have a starting amount, which is 120, and we are adding 3% onto him each month, so 1.03, and remember this is going to be time. So the equation would look like this. So if I said 1 year later, beans were going up by months, this would be 12 months of time. So we'd be 120 times 1.03 to the 12. 3% of growth onto him to the 12th power. Now the mistake kids will make is they'll want to write this down. That would be a disaster for Joey. Joey would not be alive after 1 month. When you put 0.03, you actually took 97% of him away. All right, you got to remember, you always start with 1, and you're either adding to it or taking away from it. If you're growing, you're adding. If you're reducing, you're minusing away from 1, that value. Now I got a calculator here, and I'll just punch in the numbers. So 120 times 1.03 to the 12th power, and I get Joey at 171 pounds. So that would be pretty effective. Hopefully Joey's not getting fat, because he's really gaining weight there. That's 50 pounds in a year. It's pretty crazy. Probably don't try that at home. Okay, moving on. Got another problem here, and this is going to be exponential decay. So if you notice, these values are less than 1. But I've got a river. The depth starts at 500 centimeters, and it's going down 2% every week because it's not raining. At this pace, what would be the depth after 20 weeks? Certainly don't expect you to have to set up a table. But if you see a table and they say, what's going on? Is this exponential growth or decay? Look at the factor that you're taking and multiplying with. If it's less than 1, you're decaying something down. If it's bigger than 1, you're growing it up. So this is an exponential decay problem. So let's see if we can make an equation for that. The starting point of that river was 500. It's going down 2%. So 1 minus 2% minus 0.02, 0.98. And then of course it'll be to the power of time. Now this is a week by week deal. So we are going to have 500 times 0.98 to the 20th power. Okay? Take my calculator again. 500 times 0.98 to the 20th power. And that river's down to about 334 centimeters of depth. Okay? So, there you go. Start, grow it up, multiply by 1 plus the rate, decay it, 1 minus the rate. This thing curves downward, you guys. That would be the starting point at 500 centimeters, and it's going to go downward like this, decay. All right?